Welcome to another Juniper-sponsored webinar. Today, we'll be focusing on infrastructure as a code, leveraging Junos and Ansible to enable DevOps for networks. I would like to take a minute to introduce our guest today. I'm Robert Tang, Senior Product Marketing Manager focusing on automation solutions. I will be your host today. With us, we have Stacy Smith and Carlos Vicente. I'll let them introduce themselves to you. Stacy?
Hi, I'm Stacy Smith. I'm an automation engineer here at Juniper Networks. I'm involved in both development, support, and customer education on some of our external-facing automation products, including the Ansible modules that we'll be talking about some today. And I'm also the co-author of a book called Automating Junos Administration by O'Reilly Associates.
And I'm Carlos Vicente. I'm a principal network engineer with Oracle+Dyn, and I have been focusing on network automation, but I'm also involved in network design and operations and several other things.
Our webinar today will start with the definition. What really is infrastructure as code? This is to be followed by an overview of Junos module supporting Ansible today. We'll then take a deep dive on an actual infrastructure as a code use case deployed by Oracle+Dyn, to be followed by a brief summary. Infrastructure as code is becoming increasingly widespread with the adoption of cloud services. So, Stacy, could you elaborate what exactly is infrastructure as a code?
Sure, Robert. It's basically managing an entire infrastructure, both the compute and the networking part of that network infrastructure, using the same approach that we use with modern software development. We leverage the collaboration, testing, deployment, those continuous integration techniques that we use in software development and apply them to the network. We've often heard the term DevOps to describe how this approach is applied to the compute infrastructure. So we're really just talking about extending this to be the mindset of DevOps for networks. As this slide illustrates, infrastructure as code is really the next step along Juniper's vision towards self-driving networks. It's taking that automation to the next level by testing and validating your changes before deploying them in your production network. So today we're going to hear from Carlos, one of our customers, on how he's taken this infrastructure as code approach and applied it in the Dyn network. But before we do that, I wanted to provide a little background on one of the key building blocks in Carlos' solution, and that is Ansible. And we'll talk a little bit about the Ansible automation framework and the support it has for managing Junos devices. Ansible is a radically simple IT automation platform that can be used to automate the management of both the compute and network infrastructure. As illustrated on this slide, Ansible includes extensive support for Junos devices. The idea behind Ansible is that you don't have to write a lot of scripts or custom code to deploy and automate Junos devices. Instead, you describe your intentions in tasks or playbooks, which use the YAML syntax. And YAML is a language that approaches plain English.
So there are many other open source automation toolkits that are available, such as Chef and Puppet, which, by the way, Juno OS also currently supports. But going back to Ansible, so what are the key differentiators between Ansible and this toolkit?
Yeah, one of the primary differences I see in Ansible is Ansible utilizes a push model rather than a pull model. that's used by some of the other systems. So this means that Ansible doesn't require agents to be installed on the managed devices. And it also means that the Ansible modules for Junos that we've created can be used with any Juniper device that's running a currently supported version of Junos. In fact, we actually go back and support as far back as Junos 11.4, which is past end of life. In addition, the Ansible modules for Junos support initial configuration of a Junos device over the serial console, either directly or through a terminal server. So this even allows us to use Ansible to support new out-of-the-box provisioning of Junos devices. We've created modules for Ansible that allow you to do various things on Junos devices, including upgrading the version of Junos, pushing configuration changes in any of the formats that Junos supports, getting general facts about the Junos device, such as its model or the version of Junos it's running or its serial number, those kinds of things, and then do operational tasks like rebooting or shutting down the device as well. So Juniper has provided support for Ansible since 2014. Ansible Galaxy is the repository where Ansible allows third parties to publish modules that they've created to extend Ansible. And Juniper has a collection of Ansible modules for Junos, which are published on this Galaxy repository under the Juniper.Junos role. These modules work with both the 1.x and 2.x versions of Ansible, and they allow users to execute any of the CLI commands or Netconf RPCs which are supported by the underlying Junos device. In addition, we have specific modules that simplify some of the common tasks. We already mentioned some of them, like upgrading Junos and installing or committing a configuration. But we also do things like even initiating a ping from the Junos device, as well as a new module that we have that allows you to create tests to compare operational state of Junos devices both in before and after an action happens. So these original Ansible for Junos Galaxy modules, as we call them, are shown on the blue part of the slide. The C next to some of the modules indicates that those modules can be used over a serial console connection, and so those modules are useful in initial provisioning of the device. In addition, Ansible themselves have introduced support for Juniper devices in Ansible version 2.1. This support was added in consultation with Juniper. We influence the design of these modules based on our experience creating and supporting our Galaxy modules. And so we refer to these as the Ansible for Junos core modules because they are included in Ansible core. And they're the modules that are shown in the green on the slide. And then while there's currently some overlap in functionality between these two set of modules, it's important to note that some of them do have unique capabilities and that you can use both of them in your system. They can coexist. You can create tasks and playbooks that call either the Galaxy modules or the core modules, and even mix and match them as you see fit within your playbooks. So now that I've gone over a little bit of our specific Ansible support for Junos devices, I wanted to turn this over to Carlos and see how this fits into the bigger picture. And Carlos has created a system that really illustrates this idea of infrastructure as code. Carlos?
Yeah, so we're really talking about the Dyn case. And I joined Dyn about 3 years ago. In those years, I've seen a lot of growth. Dyn has about 20 data centers in 5 continents, and we have to manage hundreds of network devices. There are multiple teams that interact with the network, and this fast growth has meant that we needed to tackle automation, and that was the main priority. What I saw was that there was automation for servers and applications, but there was little or no network automation before this effort.
So Carlos, what were some of the problems you encountered in the Dyn network when you initially joined due to this lack of automation?
Well, the lack of automation means that everything that you do on the network is someone sitting in front of a keyboard typing command line statements. And as you know, that is very error-prone. You end up with an inconsistent configuration, so nothing's the same anywhere. Obviously, if you're doing this multiple times in multiple places, that takes too long. It just doesn't scale. We also were lacking of a formal approval process. Although engineers were pretty good at letting others know what they were doing, this was not a formal procedure that had to be approved by someone else. So the result was that bad changes sometimes got introduced without review.
So were your colleagues that were managing Dyn's compute infrastructure encountering some of these same problems?
Well, not so much, because the compute side of things had been had seen a bigger effort that had started earlier to drive everything with automation. So we were ahead in that sense, but the network was a different issue. At that point, we started a project called Kipper, and the idea was basically to continue the same approach that we had been using for other areas like compute, the continuous integration approach to configuration management. And what we did was to combine a little bit of code that we wrote and also use other tools that were available. These tools were Ansible, GitHub, and Jenkins, and a protocol called Netconf that is very well supported in Juniper.
So Carlos, can you give us a little background on why you chose these particular components to integrate with your continuous integration system? Did you already have experience with these tools?
Some of them, yes. So Jenkins and GitHub for sure, because they were being used for other things. And Ansible, I did not have experience with it. However, when I started looking at how to solve this problem, all the examples I was finding at the time, and this was 3 years ago, all the examples were being shown with Ansible. So it was an easy choice. We did know that Netconf existed. We had played with it, but we didn't do anything in production. But we quickly found that the implementation was very mature. Netconf is an IETF standard for network configuration management. You'll see RFC 6241 defines the protocol. It uses XML for encoding the data and the operations, and it uses, or it can use, secure transport like SSH. We found that there was good support in Juniper, and I have not seen the same support in other platforms, unfortunately.
So Carlos, this foundation let you communicate with Junos devices in a structured way, but does that mean that you and your engineers had to actually write XML RPCs and parse XML responses here?
Negative. All the modules were already available for Ansible, so basically we did not have to interact with the protocol itself, only with Ansible.
Yeah, that's a great advantage of using Ansible here in the system. And one of the other things I'd like to point out is the Ansible modules communicate with the devices using Netconf over the SSH transport by default, but can even be used with Netconf over a serial console for the initial provisioning of new out-of-the-box devices if need be.
Correct. Ansible is an open source automation tool, very widely used, and it focuses on simplicity. And one of the key things that I found that I liked about it was that it was agentless. We had experience with other automation tools like Chef, but those require an agent, and because we didn't want or couldn't run an agent on Juniper devices, this was a key feature. The other thing I like particularly is the push model. So I like to control exactly when I make a change in a group of devices or a device, and not wait for the agent to connect to a policy server where it needs to check if there's something that needs changing. The other thing is Ansible is extensible with modules, and it just so happened that at the time I started looking at this, Juniper had just come out with the Netconf modules for it, and so we could start using this immediately. GitHub is a tool that we use for collaboration. So we share all our code, and we work on our code collaboratively using GitHub. Some of the good features that it has over just using plain Git is that you can fork other people's code, and when you make changes, you can create what's called pull requests. So you're asking the author to review the changes that you've made, and they can visually look at these changes and merge those changes if they consider that they are okay. So the web interface is very useful, and it has this thing called gists, which is a way to share quick outputs from programs or quick differences between two pieces of code or any kind of text that you need to share quickly. Of course, GitHub is a commercial product. There are other open source alternatives like GitLab that have some of the same features, so you don't need to use GitHub necessarily. Jenkins is a popular open source continuous integration, continuous development tool that we use at Dyn extensively, and it has many plugins that are available to interact with different things like GitHub, or a large number of other things that it can interact with. What Jenkins does is basically automate execution of tasks, and it can react to events. Events can come from the other systems that it interacts with, for example, GitHub. But you can also run cron jobs, so it's very flexible and useful.
So Carlos, you've talked about the various components that you're using here, but how do these work together in your overall continuous integration system?
The way all of these components work together is shown in this picture. So starting on the bottom left, you'll see there's an engineer that needs to make a change. This person has a copy of the repository where all the templates and all the configurations are stored. This person makes changes to variables or templates, and they commit that change and they push it to their copy of the repository on GitHub, and then they issue a pull request. And that pull request sends a notification to Jenkins. This runs a job on Jenkins that performs a dry run of those changes on the network. So it checks which files have changed, determines which devices it needs to talk to. It sends those changes via Netconf to the devices affected, but it does it in a commit check in Juno's parlance. So basically it's a dry run. It just makes sure that the changes pass syntax, and also it gets back a diff, a text containing all the differences between what's running in the device and what the candidate configuration is showing. Those diffs are collected and put together into a single text that is stored in a gist that we mentioned before, and the link to that gist is sent to our chat. In our case, we use Slack. And so the channel where all the network administrators are hanging out sees that someone's making a change in the network, and you have these diffs, and you can review them. And once you review, you can either get back to that person and say, no, that doesn't make sense. Or you can say, yeah, that's what we intended, and that's okay. So let's say you merge those changes. That also causes GitHub to send a notification to Jenkins, which renders all those templates again and commits the final configs back into the repository. So now we have all those changes are part of the canonical set of configurations that should be in the devices. However, those configs are not in the devices yet. That last part we did not automate. I mean, we did not let Jenkins do that part for us. We use Ansible from our workstations, and we push those changes carefully. This was one part of the automation that we considered was better suited to a human to determine, for example, you want to make that change in one site first and make sure that you're not breaking anything, even though the changes that were sent didn't seem dangerous. You want to start and be careful, start slow. So that's basically the workflow.
So you maintain some human control over that last deploy step, but the rest of the process is pretty much automated for you. And I think it's really interesting that you're using the actual production devices essentially to test your changes, right?
Yes, and that was I guess a great realization when we were designing the tool, because we were thinking of doing that offline. And then it just seemed very simple to just use Netconf to send the config to the device and have the device tell me whether the syntax is correct or not, and just show me what the changes are going to be. So it just worked great.
Yeah, I think that's a great example of some of the power that we can get with automation. It doesn't require that separate offline calculation or lab. You can actually do it on the real devices, and you get the benefit of comparing it with the existing configuration that's already in place and seeing just the differences that you're talking about, as well as you make sure that this particular configuration works with the particular model and version of Junos that you have running as well.
Exactly, yes.
So
the project is organized in a few categories. There's the inventory, where we have all the devices, and they are grouped by function, location, and other criteria. You have variables that apply to either a particular node or groups of nodes. By nodes, I mean switches or routers or firewalls. Then there are roles. Some of these are Ansible terms. But roles are a way to tie groups to templates and variables. It's a kind of a grouping of things. And I have some roles that are, or I have one role that is a common role that affects everything. For example, that common role contains everything that is a system config, like NTP or user counts and that kind of thing. And then we have roles that are per class of device. So we have a role for edge routers and that kind of idea. Dynamic inventory is a very nice feature that we found in Ansible, and it is the ability to write Python code that feeds the system dynamically. What happened was that as we started adding more and more things in Kipper in this project, we found that classifying all our devices by different criteria in a text file, in a YAML file, was very error prone. So the solution was to simplify the inventory to the bare minimum, just a list of devices. And we were able to leverage the naming scheme that we use at Dyn to classify those and group them based on their names. So we could group them by location. if the device is in North Bergen, New Jersey, then its name has that US NBN1 name, or if it's in Tokyo, etc. But also the naming scheme has the type of device that it is. It could be an edge router or a spine switch or a top-of-rack switch. And so we used a little bit of Python to create these groups, and then we create intersections of those groups. So I can say, well, I want to specify that this action is going to affect only the top-of-rack switches in Tokyo. And we have similar classifications like that. So this was very, very, very useful. And it didn't take a whole lot of Python code to achieve that. And it was a great help.
And this is kind of a one-time thing as well, right, Carlos? It's not something
so
you have to constantly write Python code for.
Correct. You write the code, and then as you change the inventory, it just takes care of it. So every time you add a new device, everything just works.
Yeah, that's a feature I really like about Ansible, that it allows this kind of customization that you can do yourself and follow your own business rules.
Right, and it's not only, I should have mentioned, it's not only device inventory, but you can also use this code to inject variables or data for each device or group of devices. So you build those data structures in Python, and then you pass them to Ansible, and Ansible has a rich source of data that it feeds the templates with.
Right.
Not everything is controlled by the dynamic inventory. There were some cases where it was simpler to just put the variables in YAML files or YAML encoded files. You can assign variables or values to variables in different places, depending on how specific you want to be. You can have variables that affect every device, and you put it in this particular directory called group vars and a file called all.yaml. And that file contains a lot of defaults. Now, if you have variables that only affect devices in Amsterdam, then you put them in the file called ams.yaml. And of course, there has to be a group in your dynamic inventory that matches that name. But suddenly, you were able to override the default values with values that only pertain to Amsterdam, and so on. At the same time, you have values that only affect specific devices, and those are placed under host vars, and you can just have a file that has the device name, and Ansible automatically will use the most specific value to feed that template.
And are you keeping all of your variables specific to a particular network device in this YAML files that Ansible supports, or is there something more as well?
There's more. So as I was saying before, with the dynamic inventory, we are able to read data from other sources and use Python to inject values into Ansible mostly in cases where the data is so much that it would be difficult to express it in YAML on hundreds of files. So there were cases where it made sense to put them in files, and there were other cases where it was easier to feed them through dynamic inventory. So a very good example of when to use dynamic inventory instead of those YAML files is when you have a lot of data that you can put in a spreadsheet. And one of the cases was a sheet where we put all the point-to-point links, all the interconnections between devices in a site. And it contains both ends, the interfaces, the VLANs, the IPv4 and IPv6 addresses. And this was much easier to maintain and modify to maintain in a spreadsheet and not in different YAML files where it would be very easy to make mistakes, because when you have a point-to-point link, obviously you can express only the prefix, for example, the /30 prefix, and the code can just assign one IP to one device and the other IP to the other device. If you had to put that in YAML files, most likely you would edit one file, not the other, and then you would have a misconfiguration. Another thing you can do is have a simple check that doesn't allow you to use the same /30 prefix in two point-to-point links, because that would be an error. So this was very, very useful, and it's one reason why we decided to use some spreadsheets for cases where there was too much data to put in YAML.
Yeah, I really like this, Carlos, because essentially you're using this spreadsheet as a very simple database, but you're also providing dynamic checks on it and actual auto-generation of some of your values, so you don't have to keep the same data in two places.
Correct.
Can you talk a little bit about that?
Yes.
I'm sorry. Can you talk a little bit about that last bullet point on your slide? You're actually keeping this spreadsheet in version control as well.
I really like this idea of keeping it in version control, because I have more control of what changed, and I can see a history of how this file was modified across time and by whom and exactly what was changed. So it gives me a lot more confidence in the system to know that the sources of data are under version control, instead of Ansible talking to a database that could be corrupted, and you'd have to constantly modify the schema if you are changing the type of data that you're entering, et cetera, et cetera. So this was a very quick and also safe way to do this.
Yeah, that's great.
Templates are a part of Ansible, and for that, Ansible uses something called Jinja 2. Jinja 2 is a tool to allows you to embed configuration text with Python code. This is not a new idea, but it's very useful because you can express your configuration in a way that is simple if you take advantage of loop mechanisms in Python, and also not just simple, but you have a lot of control over what is the output of this template if you use conditionals. One example I use is I check whether I am rendering for a particular version of Junos, and I can decide whether a particular parameter is allowed in that version or not. I express my configs in XML. At the beginning, when we started, we had some older versions of Junos that didn't support other formats, and so we stuck with XML. And in the end, we liked it that way also because XML is easily parsable, and you can load it with any programming language. But in this case, I have some basic Python code that once the templates are generated and all put together in one file, I can load the whole configuration and convert it into a data structure and traverse that data structure as a tree and check for things and make sure that it is according to policy.
So, Carlos, for people that haven't seen a Jinja 2 template before, can you kind of provide us with an example of what one of those might look like?
Sure. So this is an example of a Jinja 2 template file. And as you see, there is XML, and there are sections between curly brackets with variable names. And these variable names are what Ansible when it renders, or you could say Jinja, when it renders a template, it translates those variables into actual text. And in the end, you have only XML. In the third line, you'll see a for loop. So I am repeating that domain search statement for as many times as domains are in the domain search list. Later, you have a conditional where you only include that section if that condition is met, etc. And that's how all our templates look, basically.
And in your example here, it's an XML Junos configuration snippet, and you explained why you prefer that. But Jinja is not restricted to just the XML format, right?
Correct. Jinja can output any text, and in fact, in Junos there is support for other formats that Juniper devices interpret, like set commands or the other native format.
Yeah, great.
So before, when I showed the workflow, I mentioned that we use Jenkins to do the testing for us, and the tests are automated. In our case, the test is basically a dry run of the configuration file changes in the actual devices. In Junos, that is known as a commit check, and what comes out are the diffs between the running configuration and the candidate configuration. Or if the template that was rendered was not correct, syntactically correct, then we would get back the error messages from the device, and we would report those. What that job does also in Jenkins is to send those diffs as a unified file and put them all in a GitHub gist so that the administrators can review it.
Yeah, so this gives you the ability to do those syntactical checks and still let a human review for potential logic errors or non-compliance with some of your network rules that might not yet be automated. Is that right?
Correct. Here you see an example of what we see in our chat room when someone issues a pull request. In this case, someone is adding some routes. That causes Jenkins to run a job. As we talked earlier, GitHub is able to send that event to trigger a job in Jenkins. So Jenkins also integrates with Slack, so it lets us know that it's running something. And in the end, you see that little dog that's Kipper saying that the results are available for us. So we can click on that link, which is available here, and we see the gist with all the differences that came out of that dry run. And here, after you click on that link to see the gist, this is what you see. Conveniently, GitHub gists allow you to use syntax highlighting. So when you post something with a diff name at the end, extension I mean, you'll see green and red, which is very nice. So for each device, you will see a list of lines that were removed and lines that were added. And in this case, it's an apply group that is being changed and an MTU value. And it's the same change in multiple devices. So assuming that the changes are okay and the administrator merged those changes into the repository, those become the canonical configuration, and then there's a deploy phase. So now we need to put those configs finally in the network for good. There's a playbook in Ansible that also using Netconf sends those XML files to each device. And we can do it in parallel, and we can send configs to all the devices at once, or we can select which ones we want to send to. automatically the deploy playbook also notifies the NOC. Because at the beginning, there were cases where we were pushing changes and the NOC wasn't notified, so we made it part of the playbook so that we never forgot to do it, and they're much happier now. You can also use the same playbook to do other things at the same time you deploy. You could, for example, if you use a tool to collect your configurations and back them up in another system, you can run that. There's a famous one, it's open source, called Rancid. Another example is you could use that playbook to send an event to a time series database where over time you see when those changes happened, and you can pinpoint, when a particular problem started happening. You can go back to that time series chart and say, well, look, it coincides with the moment when we push that change. So those are things that are very useful. Another thing that we were able to do with Ansible was to program tests, functional tests. The first one was the easiest one, was to create a ping test that simulated server-to-server traffic. Because we have so many sites, and each site has different routing instances, we have a full mesh of paths that would be very complicated and time-consuming to test from every point to every other point. So that was easy to also program with dynamic inventory, and we took all the server VLANs and simulated ping traffic from the top of rack switches where those VLANs exist to every other top of rack switch. And as I said, changing routing instances each time. So it was a full mesh of ping tests that very quickly tell us whether the change we've made broke some path, and that would be something that would let us know immediately that we need to roll back the changes. Fortunately, we can also roll back changes with Ansible. So this test has been particularly useful. Also, we run the test once a day because you can configure Jenkins to run something for you using a cron job. So the test is run every day. If anything changes, we detect it.
Yeah, I really like the fact that you're testing the actual forwarding capability of the network with this tool as well to verify your deployments. Just so you know, there's also a new module that we've added in our Ansible support relatively recently for our JSnappy tool, which allows you to gather operational state from Junos devices both before your deployment and after them, and it can compare the differences and report any changes in operational state that weren't expected.
That sounds very useful, and I will definitely look into it.
Yeah. So Carlos, this seems like a really neat tool. It seems like it's offered a lot of capability to Dyn that you didn't have before it was created. What would you say are some of the lessons that you've learned from this project?
Sure. Lessons learned. I can tell you that for sure you need to start simple. It was overwhelming to try to tackle the project and every device in every site and put it all under control of this tool from the beginning. So we decided to start with the easy things that we could do quickly and iterate from there. For example, all the user accounts, NTP configurations, DNS servers, SNMP, things that were pretty much the same everywhere. Those were easy to put into a template. So we started there, and we created a role in Ansible that contains every device in the network. And that was a huge, huge win. We were very happy when we had at least that part automated. And then we started working incrementally from there. And we have not achieved 100% coverage everywhere, but we did make sure that the sites that we were remodeling and refreshing were covered 100%. So the last 6 times that we've done that, we were able to just go plug in the devices and run Ansible, and everything was configured from scratch. So that's the end goal. But you can't try and do this and cover every device 100% from the beginning, because it's impossible. When you've had years and years of doing things manually, you'll find that there are many variations and things that are hard to put into a template because there are just too many conditions that you need to check for.
Yeah, I completely agree with you, and I think it's important to know that, like you said, this can be an incremental process. You can start small with those small pieces of your configuration and kind of work your way up as you've done over the years here.
Right. The other thing that we realized was that we didn't really have to check for adherence to policy, because the template becomes the policy. And once you have a template, then it means that everything is going to be the same. And you can basically represent your policy in each template. Another thing we do is we perform these dry runs, not only when someone's changing something, but also once a day, maybe at night when nobody's doing anything, to make sure that if someone introduces a change outside of the tool, we are notified quickly the day after. We come and we see that there are diffs, and we need to decide whether those changes need to be incorporated into the templates and variables, or whether they were supposed to be temporary and we can just rerun the tool and the device will go back to what it was supposed to be.
So the entire system essentially becomes your network documentation, it sounds like.
Yeah, correct. And you can use that inventory to feed other things. You can envision using this to also configure your monitoring, for example. So the possibilities are not endless, but there are many.
Yes.
So what happens when you have changes that don't necessarily justify doing the whole workflow of submitting a change and having someone else review it and merge it and have it go through the whole thing? Well, certainly there are cases where that's what happens. I mean, if you're under attack, you need to make a very quick change. That would be too cumbersome to expect people to go through that, even if that attack is happening at 3 a.m. and not everybody from the network team is available. There are certainly many cases where you need to make changes anyways, and very quickly. So we've realized that that's okay, and that this tool shouldn't get in the way of changes like those. And what we've tried to do, besides notifying the next day that there was a change that doesn't that is not represented in the tool, we've begun to, for example, write very simple API code that allows us to do certain things that happen often via Netconf, and via an API that runs these changes quickly and without going through that workflow. This includes, for example, changing BGP announcements because you need to manipulate what you announce to a certain provider, et cetera, et cetera. Other things like packet filtering, we've started implementing FlowSpec, and those are changes that you could do through the tool if you wanted to make those permanent if you're blocking a certain type of traffic. But it's much faster to send a command to an API that then makes that FlowSpec rule spread all over the network. So those are some examples of things that were non-permanent changes that we have automated in different in other ways that are different.
Thank you, Carlos. I really appreciate sharing your automation experience with us today. One question I do have is regarding your automation experience that people tend to associate automation with job security, right? That automation will eventually replace their jobs. So can you elaborate your experience and in terms of how it affected yourself and also your team?
Well, it definitely hasn't cost anybody any jobs or their jobs. The beauty of automation is that it simplifies the tasks that nobody really wants to do because they're boring, they're repetitive, they're error-prone. You don't enjoy doing the same thing 20 times. Nobody likes that. What automation allows us to do is to use people's actual brains, their thinking skills to solve real problems that are exciting to solve and that are also an opportunity to grow your skills, develop your skills, and grow as a professional. So I don't see automation in that negative way at all. It's just not the case.
Great. Really appreciate the insight.
Yeah, thanks again, Carlos. I think it's always great to see how customers are using our products, and we appreciate you taking the time to share with us.
Thank you for the opportunity. This was fun. Thank you.
Thank you. It's an ultimate vision for a network to be self-driving. That is, where a network will automatically establish and maintain connectivity. Let's say I need to set up a connectivity between our Sunnyvale and Boston offices. Everything that happened on the back end, including access, overlay secure tunnel, either through internet or third-party MPLS providers, connection to data center, all this network establishment will happen by itself. While infrastructure as code is the next step toward Juniper vision toward a self-driving network, we're still far away from this ultimate vision. So what we are focusing on now is to break down into building blocks where a customer can immediately benefit today with network automation. And we have identified 5 key building blocks. The first building block is openness. Juniper was one of the first vendors in the networking industry to open its OS to third-party programmability. Today, Juno OS supports a wide range of automation frameworks. In addition to Ansible, we also support Puppet, Chef, and Salt. The second building block is security. As the internet evolves and network continue to scale up, security continues to be one of the most important considerations for network operators. Enhanced security feature in Juno OS allow a device not only to boot up with an authorized and signed version of the BIOS and Juno OS, but also ensure that the router boots an image that has not been tampered with. Next is telemetry. It is a collection vast amount of information in near real time to provide this information fast and organized manner. Next is control. Control is the ability to ingest large amount of data at scale, analyze this data, discard what's irrelevant, and focus only on important details. It is also the ability to make decisions based on relevant data. The last building block is being elastic. It means that network device must be capable of ingesting new capability on the fly, dropping in features and application without the need to do expensive maintenance windows and upgrades, add new infrastructure instance, and seamlessly integrate OSS with customer-developed software. I hope you found this webinar informative and educational. To learn more detail about other use cases, please visit our automation solution page on Juniper.net. Thank you for your time today. I'll see you next time.